Right, so today we're going to be looking at equations of lines. So we already had a brief look at y equals mx plus c last lesson. Now, we're not going to be using that much in our A level. We're going to rearrange things to look like that in order to read off the gradient and read off the intercept, but we're not going to be using this in order to find any equations of lines. So what we're going to be doing from now on is using a new equation, which I will give you now. Y minus y1 equals mx minus x1. So you need to learn this one, and we're going to use this instead of y equals mx plus c for most of the things we do in our A level. So some of you might realise this looks a bit like the gradient equation we had last time. So that was m equals y2 minus y1 x2 minus x1. And it's basically saying that to find the equation of a line, all you need is one point, x1, y1. So to find the line, you need 1 point and one direction, which is what we're going to say is a gradient. So if you know the gradient and you know a point, you can use those to be able to find the equation of a line. And you would have done that in your GCSE using this, but now we're a bit more grown up, we're going to try and use the proper equation of the line, which is this one here. So just to show you why that works, if you know a point, x1, y1, and you know the gradient, there's the line, and you can then say any other point on that line, xy, is described by that point and the gradient. So we'll show you how that works now. So example 1. So, find the equation of the line with the gradient of 5 that passes through the point 3 minus 2. So, we're just going to put those two values into this new equation, rearrange it to get y equals, and that will be the equation of our line. So, we've got y minus y1, so this is our y coordinate, this is our x coordinate. So, y minus 2 equals m, so the gradient 5, times by x minus x1, this is x1, x minus 3. So that is the equation of line. Now we're just going to simplify it. So we get y plus 2 equals, and expand the bracket, 5x minus 15. And then we're going to subtract 2 from both sides to get y equals 5x minus 17, which is the equation of the line. So you end up with a similar result to what you did when you did y equals mx plus c, but now we're just using this equation and putting our values into it. So let's try another one of those. So, question 2, find the equation of the line with the gradient minus 2 passing through this point. So if you guys want to try this quickly, pause the video, use the equation, use the point, use the gradient, see if you can find the equation of the line. Right, again, so we're going to put all these values in. So we've got x1, y1, there's m. We're just going to put those where it says in the equation. So we get y minus 0 this time equals minus 2, the gradient, times by x, take x1, so it's going to be x minus 1. So y takes 0 equals minus 2, x minus a minus is plus 1 there. Y takes 0, that's going to stay as y, so we just say y equals, and now expand the brackets, minus 2x minus 2. So there is our equation of line. Cool, right, so that's what happens if you know 1 point and 1 gradient. That won't always be the case though, as you're about to see. Right, so what happens when you have 2 points? So as I said before, to find the equation of a line, you need a point and you need a gradient. So we need Okay, so if we've got 2 points, let's say we've got A, which is 2 minus 1, and we've got B, which is 5, 7. So quick sketch, not to scale, A and B are there. So we've got 2 points, we don't have a gradient. So what we can do first now is use the 2 points to find a gradient, and then we're going to use 1 point and the gradient to find our line. So a few steps to this question. So first part, find out the gradient. So our gradient equation, remember, m equals y2 minus y1 over x2, take x1, which will be 7 minus minus 1 over 5 minus 2, so it's going to be 8 over 3. So we've got a gradient, we've got 2 points, so let's pick one of these points, whichever one we think looks easiest. Probably going to go for this one because it's got 2 and a 1 in, which are quite small numbers. And now we're going to take our point and our gradient and put them back into this line like we were doing before. So y minus minus 1 equals 8 over 3 x minus 2. So everything's into our equation. And now we're just going to rearrange and get y equals. So y minus minus 1 is going to be y plus 1. Times out the brackets gives us 8 over 3 x minus 16 over 3. Now, unless you like dealing in fractions, it might be easier now to times everything by 3, because both of these fractions have a 3 on the bottom. If we times everything by 3, we'll get rid of that. So I'm going to put in brackets times by 3. So we're going to get 3y plus 3 equals 8x minus 16. Now it's a bit easier to sort out, so I can subtract 3 from each side. So 3y equals 8x minus 19. And then we're just going to divide everything through by 3 to get y equals 8 over 3x minus 19 over 3. Cool. Right, let's try another one of these. So find the line during those 2 points. If you think you understood the last example pretty well and want to try it on your own, pause the video and go for it. Otherwise, watch me and I will go through this now. So first of all, again, step 1, find the gradient, because we need gradient and we need a point. So m y2 minus y1 over x2 minus x1, and equals that. So again, pick a point to be 1, point to be 2. If we take this as point 1, this is point 2. So we're going to get y2 minus 1, take y1, 5, over x2 minus 2, take 3. So that's going to give us minus 6 on the top and minus 5 on the bottom, which gives us 6/5 as our gradient overall. Now we can use that gradient with one of these points to find the equation. So I'm going to pick this one because it doesn't have any minuses in it, so it's slightly easier, but either of these will work because they are both on the same line. So different colour. So y minus y1 is going to be 5 equals the gradient 6/5 x minus x1, which is 3. And then just rearrange, expand it, etc, etc. So this time, to make it easier, actually this time let's do it in fractions, because we're not always going to want to times things through. So if we first of all expand these brackets, we get y minus 5 equals 6/5 of x minus 18/5. We then want to add 5 to both sides, but to do that we need to have a common denominator. Remember, adding fractions, you need a common denominator. So what is 5 in terms of a fraction with 5 as a denominator? And I know that 5 as a fraction like that is going to be 25 over 5. So y minus 25 over 5 equals 6/5 of x minus 18 over 5. Then we're going to add this fraction to the other side. So we get y 6/5 of x. So that's going to leave us with minus, it's not, it's going to leave us with positive 7/5. And there's our equation number 1. if we wanted to, so sometimes in the exam they will say, give your answer in the form y equals mx plus c, which is what we've done. Sometimes, however, they will want the answer in the form ay plus bx plus c equals 0. And if they ask for it in that form, it means get everything on one side and make a, b, and c all into integers, so whole numbers. So let's try doing that to this one. So if I times everything through by 5, we get 5y equals 6x plus 7. And to get it all on one side, I'm going to subtract the 6 and subtract the 7 over here. So we get 5y minus 6x minus 7 equals 0. So be careful, just make sure in the exam, if they ask for it in this form or this form, you make sure you rearrange, otherwise you can lose like a really easy mark. Okay, so we're going to be looking now at parallel and perpendicular lines, which is a bit on what we did last time, looking at parallel and perpendicular gradients, mixed with what we did today, trying to find the equation of a line. So, quick recap, parallel lines have the same gradient. And perpendicular lines have negative reciprocal gradients. So let's put all this stuff together and try and do some questions. So example 1. So find a line parallel to this one that passes through this point. So remember, to find the equation of a line, you need a point and you need a gradient. So we've got the point, we now need to analyse this line to find its gradient. So should be able to spot the gradient is 5, and there's our point. And when you've established that, it's just one of the questions we were doing earlier on today. So we're going to say y minus y1, so y minus minus 3 equals our gradient 5, because they're parallel, same gradient, x minus 2. So this will be the line parallel to this line that goes through that point, and we'll prove that in a second as well. So we get y plus 3 equals 5x minus 10. Subtract 3 from both sides to get y equals 5x minus 13. Cool, so if we sketch that and look for this point, you can see it does go through that line and it is parallel to the line that we started with. Okay, example 2 then. Right, it's a similar idea, but this time perpendicular. So we need a line perpendicular to this that passes through this point. So again, to find a line, you need two things. You need the point, you need the gradient. So if you guys want to jump ahead, pause the video and give that a go, you can. If you want me to show you how to do it, just keep watching them. So this time, the gradient, we can't just read it off. Here we said gradient is 5, we just looked at it because it's in the form y because of x plus c. This one isn't in that form. So first of all, we need to divide by 3 to get this in the form y equals mx plus c. So we're going to get y equals 7 over 3x plus 1. So the gradient of this line is 7 over 3. So now we've got one gradient and we've got a point, we can put it into our line. But before we do that, we need to remember the perpendicular gradient is going to be negative reciprocal of this. So our gradient is going to be minus 3 over 7. So now we've got a gradient point, we can just find our line equation. So if you want to pause it and give this a go. So it's going to be y minus 3 equals the gradient minus 3 over 7, x take 2. Minus minus is plus, so y plus 3 equals minus 3 over 7, x take 2. And this one looks quite complicated, so no, we'll do it with fractions again, because it's good work to do, it's good practice to do fractions. So we're going to expand this bracket, find 3 in terms of sevenths, and then rearrange. So y plus 3 equals minus 3 over 7x plus 6 over 7. So 3 and 7 to 7, easy way to do that, times 3 by 7, and you're going to get 21. So this is going to be y plus 21 over 7, which is 3, equals minus 3 over 7x plus 6 over 7. And then going to subtract this from both sides. So we're going to get y equals minus 3 over 7x minus 15 over 7. And if you wanted to, then you could times everything through by 7 because it looks a bit neater, and get 7y equals minus 3x minus 15. So that is the line perpendicular to this one, which passes through that point. Okay, so next bit today is intercepts and intersects, which are two very similar sounding words, which I often get confused. But they do mean two totally different things. So some of you might know these. An intercept is where a line crosses the x or y axis, and an intersect is where two lines meet, or where a line and a curve meet, etc. So any two things on a graph crossing is an intersect. When a thing on a graph crosses an x or y axis, it's called an intercept. So it's all about crossing over things. So first of all, we're going to look at intercepts. Intercepts first of all. So we have a y-intercept and we have an x-intercept. So let's just draw a line of these. Intercept. So if I draw a random line on this graph, there we go. We say this point, the point where it crosses the y-axis, is going to be our y-intercept. And where we cross the x-axis is our x-intercept. Okay, so we also call the x-intercept, sometimes call it a root, or we call it a solution. So x is a bit special. You kind of get that by the end of the year. X is the thing we always care about. It's the special thing. It's the thing that causes all the changes. Because of that, the x-intercept has two other names, the root and the solution. So what I want you guys to do is, if I gave you an equation of a line, can you think of how I could find the y-intercept and the x-intercept from that equation? So pause the video, just have a think. If you can't get it, don't worry, because I'm going to show you in about 30 seconds anyway. But have a quick think, how could I find these points based on this equation? Go. Okay, so hopefully some of you will have spotted we cross the x-axis when our y value is 0. So we'll write that up. We cross the x-axis. In other words, we intercept when y equals 0. And same is true for the y-intercept. We cross the y-axis when x is 0. So to find the y-intercept and the x-intercept, we just make things 0 in the equation. So let's get rid of this for a second. So if I want to find the x-intercept of this, x-intercept, I'm going to make y equals 0. So in this equation, we'll say 0 equals 5x minus 7. Add the 7 over and divide by 5. So our x-intercept is 7/5. Y-intercept, well, we know when we cross the y-axis, x is 0, so we're going to make x equals 0. So what we're doing in all these cases, we're saying, well, we know x is 0 when it crosses, therefore what is the y value when that's true? So if we put x0 into this equation, we get y equals 5 times 0 minus 7. 5 times 0 is 0, so you get y equals minus 7. So I know for this line, the x-intercept is 7/5, the y-intercept is minus 7, and I can sketch that now quickly, and you can see that that's all true. Good. Alright, next bit we're going to try and sketch some lines. So I'd like you guys to try and sketch this. So to sketch this, we need to know where does it cross the axes. Because it's a line, we can just put in a point on y, put in a point on x, join them up, and that's going to be our line. So if you guys could find the y-intercept and the x-intercept, and then we'll sketch it. So pause the video, put in y0, put in x0, find the values, put them on the axes, and see what we get. So in order to find y-intercept, we're going to make x0, so x equals 0. So we end up with 8 minus 5y, 7 times 0 is 0, so that equals 0. I can add my 5y over now, so we get 8 equals 5y, and then divide by 5 to get 8/5 equals y. So my y-intercept is 8/5. So that's already on a graph. Next bit, the x-intercepts. Well, we're going to make y equals 0, as you said earlier. So we get 8 minus 5 times 0 is 0, so 8 minus nothing, so just 8 equals 7x. So divide through by 7, we get 8 over 7 equals x. And if you join them up, it's not to scale, but that's what a line roughly looks like. So that's intercepts. Next up is intersections. Okay, intersections, we said before, is where two lines meet, or where a line and a curve meet, or anything like that. So if I just do a quick sketch, a couple sketches in fact. An intersection could be something like that, where two lines meet, or it could be something like that. So this is a curve meeting a line, and there are two intersections. So we need to be able to find out where these are. So intersections, because the lines meet, we know at this point they share the same x value. Both lines have an x value there, and they share the same y value. Same over here, they have the same x value here, and they have the same y value here, and they have the same y value here, and the same x value there as well. So because of that, because we know the same solution works for both of the equations, we can solve it simultaneously, which is a topic we're going to come into a bit later. But for now, we're just going to look at solving some linear, so just looking at lines, no curves for today. How we solve some linear simultaneous equations. So, e.g., find where the lines y equals 2x plus 5 and 2y minus 6 equals x meet. So what we're going to do, because they meet at the same points, we're going to say, well, the y coordinate is the same in both equations. So we're going to solve y equals for y equals. So if I rearrange this equation to get y equals, put those y values together, we can then solve it, find the x coordinate, and then put that back in to find the y coordinate. So if I rearrange this one, so we need to divide everything by 2. So y equals, divide everything by 2, so y minus 3 equals x over 2. Add the 3 over. There we go. Because I've now got y equals and y equals, we know the point where they meet has got to be the same. So I can just say, well, this must equal this at that point. So we're going to say 2x plus 5 equals x over 2 plus 3. So we've solved the y's together. And now we're just going to rearrange and solve this equation to find what x has to equal. So if I start off by timesing everything by 2 to get rid of this fraction here, we get 4x plus 10 equals x plus 6. I can then subtract 6 from both sides, so we get 4x plus 4 equals x. I can then take an x from both sides, so 3x plus 4 equals 0. Take the 4 from each side, so 3x equals minus 4. And then divide by 3 to get x is minus 4 over 3. So I know when they meet, the x value, actually they meet over here, is minus 4 thirds. And now we can try and find a y value by putting this back into either of these equations. So I think it looks easiest to put it into this one because there's no fraction. So we can say y equals 2 lots of x, or x is minus 4 thirds, plus 5. Times out the brackets, so y equals minus 8 over 3 plus 5. And doing this in my head, so I need 5 as a fraction. So I know that's going to be 15 over 3. So add those together and we're left with 7 over 3. Y equals 7 over 3. So again, a y value 7 over 3. So the two lines meet there, so probably something like that. Right, a couple more questions on this and I'm done for today. So question 2 on intersections, which mixes in a bit of stuff we did. Right, so example 2, we've got 2 lines perpendicular, show they're perpendicular and find the coordinates at which they meet, as you put lines up. To show they're perpendicular, that's something we did last time, so looking at how to test if they're perpendicular, and again find the coordinates to which they meet. So here are our lines, y1 equals 5x plus 7, y2 equals minus 1/5 x. Take 2. So if you guys would like to pause the video and give this a go, you should be able to do part A from last lecture, and part B, find where these 2 lines intersect. Alright, so I'll go through this. So part A, show the perpendicular, we're going to times the gradients, or multiply the gradients. So 5 times minus 1/5 does give us minus 1, therefore perpendicular. And now part B, find the coordinates at which they meet. So we're going to solve them simultaneously. So again, we can say 5x plus 7 equals that, because we know they share the same y coordinate at the point they meet. So we add 2 to each side. So 5x plus 9 equals minus 1/5 x. We could either times everything by 5, or we could turn 5 into fifths and then add it that way. That might be a nice way of doing it. So 5x is going to be 25 over 5x plus 9 equals minus 1 over 5x. We can add that on, so then we're going to get 26 over 5x plus 9 equals 0. Take 9 from each side, so 26 over 5x equals minus 9. Times up by 5, so we get minus 45, then divide by 26. Lovely question. It's minus 45 over 26. Right, last bit says find the coordinates, not just find the x coordinates, so we do need to put that back into one of these to find the y value. So if we put this back into this equation, we'll get y equals 5 lots of our x coordinate plus 7. Right, so 5 lots of that is going to be something horrible I don't really fancy doing in my head. Anyway, if you times this out, you get y equals minus 225 over 26 plus 7. Use a calculator for this, it's horrible. Add those 2 together and you end up with y equals minus 43 over 26. You wouldn't ever want to do that in your head. You could, but it would probably be a waste of time. Anyway, so those are our coordinates of the intersection. Okay, one more example before we finish for today. So example 3, find where the line 6x plus 2y equals 7 and y equals 5 plus 3x meet. So we need to find where these two lines cross. So if you guys want to pause it, you should be able to do this by now, and then I'll go through it in a second. So pause now. Okay, so we're going to basically this time put this y in there where it says y. So 6x plus 2 lots of 5 plus 3x equals 7. So that's another way of solving simultaneously. So times up this one. And rearrange. So 6x plus 6x, 12x plus 10 equals 7. Take away 10, so 12x is minus 3. And then divide by 12, so x is minus 3 over 12. And to find y, we just need to put this back into this one. So y equals 5 plus 3 lots minus 3 over 12. So y equals 5 minus 9 over 12. 5 in terms of 12 is going to be 60. So y equals 60 over 12 minus 9 over 12. So y equals 51 over 12, which I think actually simplifies. Let's just check that. So 51 divided by 12, which gives us 17 over 4. Cool. If you understood everything today, there were some horrible fractions today, but you can use your trusty classmates calculator to simplify those. If you understood all the theory or the simultaneous equation solving for where they intersect, where they intercept, then please move on to the quiz and on to the next lecture, which I think is the last one on quantum geometry.